Okay, so actually this is the last video for day 2. We're going to work on part E. I'm just going to rewrite a couple things and start over on a separate sheet of paper. So we found the expected value was 37.5. So for part C, the expected value was 37.5 people are going to buy that 87 octane gas. We're going to round that to 38 people for purposes of whole people. And the standard deviation we found was 3.062, which we're going to change to 3 people. So that's our standard deviation. And we need these because this asks, what is the probability that the number of customers who choose 87 octane gas will be within 1 standard deviation of the mean? So here's my 38 people. This is my mean, my expected value. 1 standard deviation within that is 38, 39, 40, 41 people above and 3 people below, so 35. So we're looking at what is the probability that they fall in this little area right here. So basically that's the probability that 35 is less than or equal to x is less than or equal to 41. So if we split this into 2 probabilities, we're looking for greater than 35 and less than 31. But the problem is this is something that we really would like to do on our calculator, because this is at least. All the probabilities that we've had are greater than or not greater than, they're just equal to, like exactly. So the way you'd have to do this using the formula gets a little bit, it gets really nasty. If I just wanted to do like the probability that x is less than or equal to 41, that would mean I'd have to find the probability that x equals 41 plus the probability that x equals 40 people plus the probability that x equals 39 people, all the way down to the probability plus the probability that x equals no people bought that kind of gas. And so what that means is we have to use this binomial probability for every single number from 41 on down to 0. And that gets to be a big mess. So the really nice thing is our calculator has a command that will do these less than probabilities in the binomial distribution for you. So the way I can do this on my calculator, there's a command, there's a binomial CDF. And what you type in for your commands, you type in you type in n first, the number of trials, n, the number of trials. And then second, you're going to type in your x value, or sorry, the p, the probability of success. And then finally you type in your x value. And this is going to find probabilities less than or equal to x. So this finds the probability that x is less than or equal to the x value. That's what this command finds. So it will actually find this probability for us. Now that's not everything we need. The bad part is that it finds everything over here below 41. Okay? And then we're going to have to find, it says greater than 35, but the easier way to do this is to find everything less than 35. Since this command only does less than, I'm going to then find, so my strategy, I'm going to find this probability, the probability that x is less than or equal to 41, and then I'm going to find the probability that x is less than or equal to 35. And now I have to be kind of careful here because I want the 35 included in here. And if I include it in this, then what's going to happen with these, if I have everything over here and everything below 35, and I want this, what I have to do is subtract these 2 values, subtract those 2 probabilities. But then what I would have done is I would have subtracted the 35 out, because this included the less than or equal to. So really I need to find the probability that x is less than or equal to 34, so I keep the 35 in there. Alright, so that's my strategy. So I am going to do the probability that x is less than or equal to 41. Okay, so the way I do that, the probability that x is less than or equal to 41, I'm going to do binomial CDF. Okay, and to get to binomial CDF, to get to that, you're going to hit second, distribution. So on your calculator, you're going to hit second, and then distribution. And then you're just going to go down until you find the binomial CDF. I have one of them it's A, the other it's B, so I guess your calculator might be different. So binomial CDF, hit enter. And now the number of trials, N, was 50. So N is 50. And P is 0.75. And my X value is going to be 41. Okay, again, I'm finding this probability here. And that value is 0.9084. Now I'm going to do the same thing, second distribution, and I'm going to go down to binomial CDF. I'm going to do it for 34 now. Okay, so 50, it's still 50. The probability of success is still 0.75, and the X value this time is 34. Hit enter, and we did that because we want to keep the 35 within our standard deviation. Okay, so this one is 0.1631. 0.1631, and then we said we would subtract those two, so 0.9084 minus 0.1631 gives me 0.7435, 0.7453, sorry. So that is the probability that it falls within one standard deviation of the mean, which is 0.7453. Okay, a little bit higher than the actual 68% that it should be, but that's okay. That's okay. This isn't a normal model. It's a binomial model. All right, so your homework number 2 for this semester is page 402. You read the pages that I talked about at the beginning of the first video, and then page 402, 13, 17, and 19. So, all right, thank you very much.